Okay, this next section is about the Arrhenius equation. It's a mathematical relationship which expresses dependence of the rate constant on temperature. And this was originally how it was expressed here. Okay. And where E is just the anti-log, E sub A is the activation energy, R is gas constant of 8.31, temperature has to be in Kelvin, and A is a frequency factor. So the symbol A, the frequency factor is constant, and so when it's rearranged to solve for that constant, what I end up with is the natural log of K2 over K1 is the activation energy over R, and R is still 8.31 minus 1 over T1 minus 1 over T2. This equation should look very familiar to you because we did the Claes-Claiborne equation, in which we did basically this was the vapor pressure and the delta H of vaporization. However, the formula that is given to you in the text doesn't have this parentheses around here, but it's very important to basically recognize this parentheses because you have to have both K2 and K1 in order to do the natural log. So natural log is a mathematical function like multiplication, division, addition, subtraction. I can't just move K1 out without having K2 and having done the natural log of this. So the first problem is that it's a first order rate constant in which the methyl chloride is reacted with water to produce methanol plus hydrochloric acid. And it tells me that all that was to say that K is equal to 3.32 times 10 to the minus 10th. My temperature is 25 degrees C. So now we're actually going to be using temperature. It wants to know what is K. So that's my equals. Is equal to what? At 40 degrees. And it tells me I have an E sub A of 116 kilojoules per mole. Okay, so the equation is natural log, and like I said, the parentheses is important, of K2 over K1, oops, big parentheses, is equals to E sub A over R times 1 over T1 minus 1 over T2. So temperature has to be in Kelvin, so I make 225 degrees is 298 K. The 40 degrees Celsius is 313 K. What was not on the previous slide is R is a value 8.31, and it's in joules. So the E sub A, and this is just like what we did in the delta H equations, the E sub A has to be in joules. So basically I multiply by 1,000 to get 116,000 joules per mole. And I'm now ready to start substituting. Oops, I'm not quite ready. I should say, what's important is to identify what is 1 and what is 2. It doesn't matter mathematically. You can solve it either direction. However, since this is a fraction, having K2 as my unknown on top of the fraction is easier. So I'll make this one 2 and make this one 1. And I do this because I want to make sure that I have the right K linked to the right temperature. So when I do this, I get natural log of K2 is what I don't know over 3.32 times 10 to the minus 10th is 116,000 divided by 8.31 over 1 over T1 was 298 minus T2, which is 1 over 313. That really is a 3. Okay, because this is a fraction and it's inside here, I can't do anything to this side just yet, so I'm going to keep it the same, K2 over 3.32 times 10 to the minus 10th. When I divide 116,000 divided by 8.31, I get 13,959.1. When I do this parentheses of 1 divided by 298 minus 1 divided by 313, I get 1.60 times 10, 608, times 10 to the minus 4th. there, times 10 to the minus 4th. Again, I can't do anything to this yet, so I'm going to leave it as is, K2 over 3.32 times 10 to the minus 10th. When I multiply these two figures together, I get 2.245. Now, okay, I am ready to get rid of the natural log. So on your calculator and just in rules, the opposite of natural log is e. So I do e to both sides. That gets rid of the natural log, so I'm left with K2 over 3.32 times 10 to the minus 10th. E to 2.245 gives me 9.439. Now I multiply both sides by this 3.32, so K2 is 9.439 times 3.32 times 10 to the minus 10th. And when I multiply those two out, I get, 3.13 times 10 to the minus 9th. And I'm not, again, this is a rate constant, so I'm not going to worry about what it is. Let's see if this makes sense. Okay, my temperature increased from 298 to 313. As my temperature increases, what should happen to my rate law? My rate law should also go up. In fact, 3.13 times 10 to the minus 9th is in fact larger than 3.32 times 10 to the minus 10th. Okay, so I'm going to end this video here, and we'll do another problem on the next video.